Hello, everyone. So, for all of you who may have missed class or just had a bad connection issue today, I wanted to make sure that you had a chance to see what we went through and what we lectured about. So, here is your assignment for today, whether you're in period 6 or 1, 2, 3, or 4. We're looking at Investigation 5, Energy Transfer Part 2. So, we're going to continue what we started earlier in the week. Now, I've attached both of your assignments to this team's assignment so that you know where you can go to get points. So the quizzes assignment will be today's assignment for class, and the Microsoft Forms assignment check will be your homework, and we'll talk a little more about those. So we want to start by opening the Energy Transfer Part 2 PowerPoint. And so in continuing what we started, our focus question for today is how does energy transfer from one substance to another? So we've talked a lot about gases and solids and liquids and how those particles act with each other, but today we want to focus on how the energy transfers between them. And this question is very important because it will pop up in your quizzes assignment as well. So the vocabulary, make sure you take a look at this. It is the same vocabulary from earlier in the week. Conduction, the transfer of energy from one particle to another as a result of contact. So that's really important. Conduction happens anytime particles bounce off each other or vibrate against each other or are moving like a liquid and hit each other. So that's conduction when we have that energy transfer. Cooling is the energy transfer that decreases the kinetic energy of a substance's particles. So anytime we have a decrease in the kinetic energy, we're cooling. And opposite of that, we have heating anytime we increase the kinetic energy. Now, equilibrium we'll talk about a little more towards the end, but you can think of it like a room. And so equilibrium is a condition in which a system is experiencing no net change. So if we had a room that was completely sealed off from the outside, then the temperature of the room, all the energy in the room would stay consistent. It wouldn't change. But as soon as we open a door or open a window, that energy is going to change, and we will have a net change, okay? So it would move away from equilibrium. And we'll look at that more at the particle level as well. Lastly, we have energy transfer, and that's a movement of energy from one location to another. So we know that's part of conduction, right? Because transfer of energy, that's energy transfer, the movement of energy from one location to another. Conduction is when it results from the contacts of two different particles. So these all go together. It's really important that you guys know these. So you can see down here, words have power, right? Vocabulary is very important. Now, our third slide, energy transfer, mixing hot and cold water. So I want you guys to think about what this video, and let me get it started here for you. So what will this mixture look like? We have hot particles on the left. We have hot water on the left, and we know it's a liquid. We have cold liquid on the right, and that's why they're blue. Now, what's going to happen is we're going to mix them together. So what's going to happen at that particle level? What happens when we mix hot and cold together? Let's take a look. Now, the result, as you can see, turns purple. So we have a different kinetic energy. That's what it's trying to tell us. The red hot particles ended up losing energy. The blue cold particles gained energy. And the result was a purple particle, which was somewhere in the middle of those two temperatures. So when we transfer energy through those particles hitting each other, we have conduction, and we'll talk about more soon what those temperature changes look like. So we'll put some actual numbers to them. But the big idea for now is that when we have particles that come into contact with one another and transfer energy, the energy transfer is always from higher temperature to lower temperature. And that's really important to understand, high to low. And that's because we have a transfer of heat. We have a transfer of energy. And low temperatures don't have as much energy. And we know that because when they do, the particles move faster. Their kinetic energy is higher. So we always move from high to low. Energy moves from an area of higher kinetic energy to lower kinetic energy, or from a higher temperature to a lower temperature. So energy transfer between particles always moves from particles with more kinetic energy to the particle with less. And we're going to look at that in this example here. And this is something you can do on FOSWEB as well. There's a link right here that will bring you to FOSWEB. And it's an activity called energy transfer by collision. And all of you are able to access that if you log into FOSWEB. But let's look at it here. So in gases, and we've talked about gases a lot, particles fly through space. Some fly fast, as you just saw there. The red particle has more energy, it's hotter, that's why it's a red color. And others have less kinetic energy and move more slowly, as we just saw right there. So frequently, as we just saw, those particles collide, and when they do, energy transfers from fast moving to slow moving. Let's look at that again. And what you see, just like the first time, is that when these particles come into contact, their kinetic energies change. The red turns to purple, and the bluish purple turns to a dark purple. And that's because when particles collide, and we have that transfer of energy from the higher energy to the lower, the energies are the same when they come out. They transfer an equal amount so that they're the same. And of course, they go on and hit other particles and transfer energy a little more because they aren't perfectly the same. But the idea here is that after a while, inside a room such as the system we were talking about, we would have an equilibrium. All of the kinetic energy would be the same. Those particles would be similar because they've worked out after a while hitting each other and transferring the energy to where the equilibrium has been achieved, okay? And so what I put on our next slide was the first law of thermodynamics. And this tells us that the amount of energy in a system does not change, and energy is not created or destroyed. And this is a really big idea. When we talk about energy, such as in a system like the room we were talking about, energy doesn't suddenly get created from nothing. And it also doesn't get destroyed. So that's why when we say if we had a closed off room where nothing could get in or out, and we had that system, we would be able to measure the energy in that room, and then by keeping it closed off, show that it does not change because energy is not created or destroyed. So this isn't something that's going to be on a test or a quiz, but it's just something I want to show you guys in the future. You're going to learn more and more about the laws of thermodynamics. And that word thermo, remember, it means heat. So you know when you hear thermodynamics, we're talking about heat. So just read over this one, but it's not going to be on any quizzes. Now, our next activity is also on FOSWEB, and what we're going to do is we're going to go through it together, but I do challenge you to work on this by yourself and make sure you understand which way energy flows. So when we log into FOSWEB, we of course want to use our student ID numbers at student.tusd.net, and your password is your 8-digit birth date. Now once we log in, we have this chemistry book. We're going to click on that. We're going to click on the energy flow activity. Now, the first thing we want to do is we're going to drag the temperatures to their appropriate spots. So, it tells us that the outer tub is -10. This area out here is the outside tub, and we have an inside tub, and the rest of the room is filled with air, so that's the room. So room, we're going to put at 20, outer tub at -10, and inner tub at 40. Now, what we're looking for in this activity is drag and drop the arrows to represent the energy flow. So, which way is energy flowing between the 20-degree air and the 40 degrees Celsius water? Now, when you think about this, it's important to remember energy always flows from a higher kinetic energy to a lower kinetic energy. And we know something that has a higher kinetic energy is going to be higher in temperature than something with a lower kinetic energy. So here we're looking at kinetic energy as a temperature, because if you remember last week, we discussed how temperature using a thermometer is a measurement of the average kinetic energy of a substance. On Monday and Tuesday of this week. So we need to find which of these temperatures is higher than the other, and then we will point an arrow in the direction of the lower temperature, because we know energy flows to the lower temperature, or the less kinetic energy. So 40 degrees Celsius and 20 degrees Celsius. If we look at Celsius temperature scale, here's a good one where we can see negative and positive. Oops, awesome. So 0 degrees on a Celsius scale is where water turns to ice, where it starts to turn to ice. Water doesn't all automatically do it at once, but it begins to freeze and turn into ice. So the Celsius scale is really nice because water at 0 freezes. Water at 100 degrees boils. So we have some phase changes, and we'll talk more about those phase changes again in the coming weeks. So when we look at 20 degrees Celsius and we look at 40 degrees Celsius, we need to figure out which one is higher. And on scales, when we move up above 0, we are going higher in temperature. And as we come back down, we go lower. Now, it's important to know as you come lower, we can go below 0. And below 0 are going to be negative numbers. But the bigger those negative numbers get, the lower in temperature you're going. So don't confuse these as we go lower, because there are going to be some negative temperature questions on your energy flow, such as a -10. So if you need to pull up a scale to look at, that's perfectly fine to help you out, because remember, once again, we're looking for the flow of energy. Which way does energy flow? So 40 degrees and 20 degrees. When we look at our scale, 40 degrees is higher in temperature than 20 degrees. So energy is going to flow from high at 40 degrees to 20 degrees Celsius. So we lose energy from water into the air. Now over here, we have -10 degrees Celsius. That's frozen ice. And we have 40 degrees. Now 40 degrees is decently warm, and -10 is very, very cold. So we know energy always flows in the direction of the cold. I'm going to put it this way. Energy flows from 40 degrees Celsius water to the -10. Now lastly, we have a -10 degrees Celsius and the air in the room. And if you remember up here, we have 20 degrees Celsius. So 20 degrees Celsius out here and -10. We're going to have energy flow from the 20 degrees Celsius air to the ice. And we can click check me. And if it actually works, it will let you know whether you got them wrong or right. So make sure you do this activity yourself. Do it a couple times until you get them right. This will be something that some questions on maybe some quizzes soon will come up. Now back to the PowerPoint. The homework that you need to go through today after working through this assignment, and make sure you do the activities as much as necessary. Your first assignment for class today is to click this quizzes link for energy transfer. And your 5 questions, which I mentioned earlier, are going to be from the vocabulary terms. So there are 4 of these 5 terms, multiple choice questions on which one's which on your quiz. And the 5th question is this right here. How does energy transfer from one substance to another? So make sure you figure out these answers before, you look them up, you listen back to this lecture a little bit, and try to find those out so that when you take the quiz, you only have to take it once. And so that's your 10 points for the assignment today, but your homework is a Microsoft Form assignment check. And so this goes back to a lot of students in most of my classes are missing way more assignments than I think you should be. So I just want to make sure we know what's going on. So answer this honestly. Are you able to log into Aries to check your grade? If you are, what is your current grade and how many missing assignments do you have? I want to make sure you guys are aware of what's going on because it worries me for some students who have a lot of missing assignments at this point in the quarter already. So answer honestly and then tell me what you could do to help your grade. I let you guys know that I have office hours Monday, Tuesday, Thursday, and Friday from 1 to 3, so you guys can come by and get help at any time. A lot of students have, but make sure you know it's there as well so that you don't receive any bad grades because of missed assignments you may or may not have understood. So use that wisely. And lastly, I put both of these in case you weren't able to click them from the PowerPoint. Both assignments are right here. So Quiz's assignment is today's assignment from class, and the Microsoft Forms assignment check will be your homework. If you have any questions, email me or come by my office hours next week.